هذه الندوة، وهي بعنوان الصيانة الدورية والوقائية ودورها الفعال في تحقيق السلامة في مرافق الإمداد بالطاقة الكهربائية. وأدعو المتحدثين ورئيس الجلسة إلى المنصة مشكورين حتى نبدأها.
محمد آله وصحبه أجمعين. الدكتور صالح العواجي، ضيوف الكرام، نشكر لكم حضور الندوة الثالثة لخبراء السلامة الكهربائية واهتمامكم بحضور هذه الجلسة بشكل خاص. أعزائي، موضوع هذه الجلسة هو الصيانة الدورية والوقائية ودورها الفعال في تحقيق السلامة الكهربائية في مرافق الإمداد بالطاقة الكهربائية. وسنتناول هذا الموضوع من خلال 3 محاور سيقوم خبراءنا الأكارم بتقديمها بالتناوب. وهنا أهيب بالسيدات والسادة الحضور بالاستماع جيدا للتقديم والمحاضرات، ومن ثم إثراء الجلسة بالأسئلة في الوقت المخصص في النهاية. هنا نبدأ بالمحور الأول، وهو بعنوان نظرة على السلامة الكهربائية من خلال التصوير الحراري بالأشعة تحت الحمراء مع أمثلة حقيقية. وسيقوم بتقديم هذا المحور المهندس محمد أحسن. المهندس محمد أحسن مهندس طاقة أول في شركة القراءات العربية بالمملكة العربية السعودية المخصصة في التفتيش على المنشآت والتحقق من السلامة وتدقيق الطاقة. حصل المهندس أحسن على درجة الماجستير في إدارة الطاقة ودرجة البكالوريوس في الهندسة الكهربائية من جامعة الهندسة والتكنولوجيا في باكستان، ولديه خبرة واسعة في مختلف مشاريع الحفاظ على الطاقة والسلامة الكهربائية في القطاعات الصناعية والتجارية، وقد نفذ عمليات تدقيق الطاقة لحوالي 80 وحدة صناعية واستخدامات التصوير الحراري في ذلك، وشارك في العديد من المؤتمرات التخصصية في مجال الطاقة الكهربائية. فليتفضل مشكورا.
Thank you very much. First of all, I would like to thank the organizers for giving us the opportunity to present a paper on infrared thermal imaging with real-time examples. I will start with the presentation outline. We have some statistics for electrical fire. Then we will discuss the root causes of electrical fire. Then we have one of the most important tools used as a preventive maintenance, that is infrared thermography. Then we will discuss some applications of infrared thermography, mainly the electrical applications. We have one case study for a high-rise tower in Riyadh where we conducted infrared thermography. I will share some findings and our recommendations, and then we will conclude our presentation. So the fire constitutes a more important problem than we generally know. The deaths and injuries caused by natural disasters, including earthquakes, tornadoes, floods, and hurricanes, are just a fraction of the deaths and injuries caused by electrical fire. According to one statistics, the deaths caused by natural disaster are about 400 per year average, as compared to the deaths caused by electrical fire, which is more than 4,000 per year. So this shows how important this matter is. According to the estimate of Electrical Fire Administration, United States, around 12 to 16 billion US dollars is lost every year because of the fire incidents. Same is the case with Saudi Arabia. As you can see, up to 20 million Saudi riyal have been lost in the air because of the fire incidents. And more than 10,000 cases are reported every year because of the electrical fire. And as we discussed yesterday, most of these fire incidents are directly or indirectly related to the electrical issues. Coming to the next slide, which is the root cause analysis. For the root cause analysis, there are 3 main areas to look into. One is the design, installation, and operation and maintenance. Now, safety is a very important issue when you are designing an electrical system. The 4 most important thing is that the people who are involved in design must be professional electrical engineers. One cannot adhere to minimal requirements of codes and standards to ensure electrical safety. One has to look into the more strict standards for specific cases. I'll give you one example that, for example, when you are designing for a high harmonic load, one has to oversize the neutral conductor to avoid overheating. So factors like these must be considered when you are designing a safe electrical system. Secondly, installation. Again, the foremost important thing is that the people who are involved in the installation must have electrical installation certificates. The team should be professional, and the company which is responsible for the installation must issue electrical installation condition report after the completion of installation. Our main focus today is the operation and maintenance, mainly the electrical preventive maintenance program, which we will look into the coming slides. Now, the electrical short circuit is never the root cause of electrical fire. It is only a stage which starts with the insulation failure and ends in the electrical fire. The root cause always lies either in the deficiency of design, manufacturer, operation, maintenance. For example, if we consider overloading which results in excessive amount of currents. As you know from the Ohm's law, power is equals to square of the current into resistance. So as the excessive current, because of this excessive current, the heat dissipation will increase. Means your useful energy is being lost in the form of heat, which will result in heating your conductors. The heating of conductors will eventually result in heating of your insulation of the conductors. This heating of the rise in temperature may be high enough to cause burning of the insulation material. The short circuit may occur at the later stage, but it will never be the root cause of the electrical fire. Similarly, failure of pressure contacts in the electrical system may be the cause of electrical fire. The arcing and the short circuit will be the later stage phenomena, but the root causes will lie either in the design, installation, or preventive maintenance. Coming to the preventive maintenance, we will discuss one of the most important tool used for preventive maintenance, that is infrared thermography. Now, infrared thermography is a non-destructive method to determine the heat distribution in an object. The system used for this purpose must be able to transform a visible image into an infrared image. As you can see in the figure, the three fuses are shown. The fuse image has been transformed into the infrared image, and you can see the temperature scale also. This temperature scale corresponds to the temperature of the image. Now, using this technology, you can easily know the spot temperature of each and every area by using infrared thermal imager. It has got many applications. You can use it in electrical, mechanical to inspect the building envelope, but our main focus here will be the electrical applications. Now, to compare the two technologies, one is the infrared thermometer, which is very commonly used in many commercial and industrial applications. But infrared thermometers are only good for single spot temperature only. When you are inspecting a complete system, there is a high probability that you may miss a critical area when you are using an infrared thermometer and not thermal imaging camera. As you can see here, a thermal imaging camera of 60 by 60 pixels is equal to using 3600 IR thermometers at the same time. So this shows how beneficial this instrument is as compared to the old technology IR thermometers. Coming to the applications of thermal imaging, we have conducted plenty of surveys and we have found that the main cause of high electrical resistance. When there is a hot spot, it is mainly because of the high electrical resistance. Now, what does this high electrical resistance do? Again, from the Ohm's law, power dissipation is I square into R. It means as this resistance increase, it will result in the power dissipation in the form of heat. Means again your useful energy is being lost in the form of heat. Also, this increased resistance will cause additional voltage drops, which will result in the increased current. So as the current increases in your conductors, the temperature will eventually increase, and this will result in accelerated aging of your equipment. We have found that the high percentage of problem occurs in the connections and terminations, mainly the copper to aluminum connections. For example, if your lug is connected to the conductor, they should be operating at the same temperature. A temperature difference will highlight an important anomaly. Next application of infrared thermal imaging can be circuit breakers, which are very commonly used for opening or breaking the circuits. The hot spot on the circuit breaker will indicate whether maybe the the contacts of the circuit breakers are corroded or oxidized. Similarly, for capacitor units, which are very commonly used for improving the power factors, if you have many capacitor units of same kVAR size, they should be operating at the same temperature. The difference in the temperature will indicate a possible anomaly. Maybe the cell is not working up to its potential, or maybe your fuse is blown. So in this case, we are looking for the cold spot instead of the hot spot, because the capacitor, if not working, will be cold as compared to the working capacitor, which will be operating at a higher temperature. So this shows that when we are inspecting using thermal imaging camera, we are not always looking for the hot spot. A cold spot may be a possible anomaly in the system. Another important application is the transformers. As you can see in the figure, the bushings of the transformer, the hot spot may be anywhere on the bushing, on the top of the bushing, on the bottom of the bushing, or somewhere in the middle of the bushing. If you see the hot spot on the top of the bushing, it means it's due to the improper connection, improper wire connection. If the hot spot is at the bottom of the bushing, this is a clear case of the internal problem in the transformer. And if the hot spot is somewhere in the middle of the bushing, it means the bushing is probably bad. So there are different applications which can be looked into for transformers. Then there are some small applications such as lighting, where the hot spots are due to the poor connection or the overheating of the ballasts. Coming to the case study we performed for a building in Riyadh, it's an 11-floor building. It has a very luxurious architect design, high-cost building. But we found that the annual maintenance there is very poor, only one labor, and that is also unskilled, and there is no preventive maintenance program. The fire incident took place in the building. As you can see, a short video of the fire incident. The fire incident took place in the building in July 2012. The fire took place on the roof of the building where all the critical equipments are placed. All the AC equipments and some critical electrical equipments are placed on the roof of the building. So we were requested by the building management to perform infrared thermography and the visual inspection of their electrical system. It was also required by their insurance company to perform infrared thermography before they renew the insurance for the same building. So our team comprised of electrical engineers, and we were using FLIR system P660 infrared thermography camera. We were having our R-flash personal protective equipment, power clamp meter to determine if there is any overloading of the circuit, and a digital camera. For the classification of the fault, we were using a principle that temperature difference based on comparison between similar components under similar loading. For example, if the two circuit breakers are operating at the same load, they should be operating at the same temperature. Difference in temperature may be a sign of a possible anomaly. So we were our classification was based on this principle that if the temperature difference between the similar components and the similar loading is 1 to 3 degrees centigrade, this highlights the minor anomaly. And as the temperature increases 4 to 15 degrees centigrade, then this is the intermediate anomaly. And the temperature difference, if it is 15 degrees centigrade between the similar components, then this is a critical finding and will require immediate repair. So based on this classification, we performed the infrared thermography. Here I would like to discuss some of the findings by our visual inspection. We found that the arrangement of the cable in the cable trench is not proper. Now this is a clear case of deficiency in design because the spacing, grouping and derating factors have not been considered at the design stage. Similarly, we found that the wiring of the AC units which are placed on the roof, the top floor, are in PVC conduit and exposed to humidity, rain and temperature. Again, this is a clear case of deficiency in design because they are very clearly exposed to the outside environment. So we recommended to use EMT electrical metallic tubing or RGS rigid galvanized steel conduits, and all the equipments on the roof must be weatherproof. Then one of our finding was that the burned cable, which was a result of a previous fire incident, are still there, which is causing too much dust in the system. This is a case of deficiency in operation and maintenance. We recommended the removal of burned cables and, of course, the dust. Fourth finding was that the arrangement of the cables in the electrical panel is not proper, and there are many bendings in the cable. Now, this is the issue of deficiency in the installation, because the bending in the cable will result in more mechanical stress on the cable and, in turn, increase the temperature.
Engineer Muhammad, can we close?
How much time?
1 minute.
Okay. I would like to discuss some infrared thermography findings of the survey. As you can see in the first image, the temperature in the first two phases is very high. After some study, we found that this is due to the corroded connection, which is causing the rise in the temperature of the first two phases. In the second image, you can see the hotspot is on the branch circuit breaker itself. This was a clear case that the contacts of the circuit breaker were very much oxidized. In the third image, you can see the whole wire was hot. And after the study, we found that this is due to the overloaded circuit, and we recommended to upgrade the size of the circuit breaker and the wire itself. In the fourth image, you can see the hot spot on the red phase. This was due to the improper connection, the improper bolting between the bus bar and the circuit breaker. We have performed many thermography surveys. I would like to discuss some other findings which we have recently found in a thermography survey for a cement company. As you can see, in the first image, the hot spot is on the current transformer. This was clearly due to the improper wiring of the current transformer, which increased the temperature of the current transformer itself. Next, we have very interesting finding. As you can see, the three phases cables which are passing through a support. It was a steel support from which the cables are passing. And we found that the temperature of the steel support is more than 100 degrees centigrade. After some study, we found that this increased temperature of the steel support is due to the eddy current. The eddy current is causing the heating, which is increased the temperature. Okay. So we can conclude that this is a very good technology, very fast, reliable technology for the inspection of the electrical equipment, and it can be used as a very successful tool for predictive and preventive maintenance. Thank you very much.
Thank you very much, Muhammad. Interesting topic. أرحب الآن بالمهندس محمد سفياني، مهندس كهرباء بإدارة الخدمات الاستشارية في شركة أرامكو السعودية. حصل المهندس محمد على درجة الماجستير من جامعة ولاية كاليفورنيا، ودرجة البكالوريوس في هندسة القوى الكهربائية من جامعة دمشق، ولديه خبرة متميزة في مختلف مجالات الطاقة الكهربائية، وسيكون موضوع محوره هو السلامة الكهربائية من القوس الكهربائي، تفهم المخاطر والتخفيف منها. فنرحب به.
Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you, Ahmed, for introducing me, and thank you for everybody for attending this session. It is my pleasure to be with you today. The paper that I am going to introduce is a collaborative effort between me and Mr. Rakan Ramhayani from Saudi Aramco. We are here to talk about an essential subject that may affect our lives, our beloved ones, or our colleagues. We are here to convey a message and alert you about the risk of arc flash, as there is no single solution will eliminate this hazard. With this, my presentation will start with several facts and misconceptions about arc flash safety. Also, I will walk you through the recent update of National Fire Protection Association and National Electrical Code. After that, I will share with you our experience in regards to the challenges that we faced and our approach to resolve them. Then, I'll provide you with our feedback on arc flash mitigation technologies that have been implemented at Saudi Aramco. Finally, I'll conclude my presentation with recommendations to the industry and to the safety authorities. As many of you know, arc flash energy is quantified in calorie per centimeter square, where 1.2 calorie per centimeter square could cause a second-degree burn if it is directed to the skin for 1 second. Actually, the purpose of this presentation is not to talk about arc flash history. None of the less, I will remind you with some facts and fictions when it comes to arc flash safety. The first fact is third-degree burns are not curable. The purpose of arc-rated PPE is to limit the hazard to the second degree only. Heavy PPE will protect from arc flash. That's not true. PPE will not protect from energy greater than 40 calories per centimeter square, as the blast pressure will be the dominant factor in this case. Third-degree burns cost $4 million per patient per year only for treatment. Low-voltage equipment is not dangerous. This is not true. As a matter of fact, low-voltage equipment is more dangerous since the exposed part in the equipment will be more accessible than high-voltage equipment. More fault clearing time results in a higher arc flash energy. That's true. As you know, time is a factor that will allow arc to expand. Maximum utility short circuit causes worst case arc flash energy.